Yesterday we have discussed some of the components of exception handling. We have seen the hierarchy of exceptions. We have what's exception means whenever there is abnormal situation in the application, okay, and if it is recoverable, then it is called as exception. And if that abnormal situation is not recoverable through the application, then it is a error. Errors are two types: compile time errors and runtime errors. Okay, the errors that are recognized by the compiler or the errors that are syntactical are called as compile time errors. Okay, the errors that are recognized by the runtime environment are called as runtime errors. Okay, the runtime errors cannot be recovered. Okay, and coming to exceptions, the exceptions can be recovered through the application. Exceptions are also abnormal situations, but the abnormal situations can be recovered through the application. Now, exceptions are of two types: checked exceptions and unchecked exceptions. Okay, checked exceptions are the exceptions that are recognized by the compiler. Unchecked exceptions are the exceptions that are not recognized by the compiler but recognized by the runtime environment. Okay, so for all the exceptions, throwable is a superclass. We have discussed already. We have a class throwable in the package java.lang. The throwable is the supermost class in the exception hierarchy, and subclass to throwable we have exception java.lang.exception. Okay, and all the checked exceptions are subclasses to java.lang.exception, and all the unchecked exceptions are subclasses to runtime exception, and in turn runtime exception is a subclass to exception. So exception is a superclass, both exception as well as throwable. These two are superclasses. These two are superclasses. Exception and throwable. These two are superclasses. These two are superclasses both for checked exception and unchecked exception. Okay, exception and throwable. These two are superclasses for both checked exception as well as unchecked exception. Okay, in order to handle the exceptions, okay, how the first we have seen how the exception is being raised. When the exceptional scenario is recognized by the runtime environment, for that exceptional scenario, the runtime environment will create an object. The runtime environment will create an object for that exceptional scenario. Now in the ninth statement we have exceptional scenario which is class exception, and for each and every exception there is a class. Each and every exception is represented by a class. Okay, when that exceptional scenario is arised, okay, when that exceptional scenario is recognized by the runtime environment, then the runtime environment will create an object for that class. For object for a class which represents the exception scenario. For each and every exception scenario, there is a class that represents the exceptional scenario. So, when the exceptional scenario arises, the runtime environment will create an object to that exception class, the object to the corresponding exception class, and when an unhandled exception object is observed by the runtime environment, it will block the process of execution. So, if we suspect some statements or some statements may raise exception, then what we do is we keep that exception suspectable statements in the try block. Okay, and in the catch block we write the exception classes. Okay, and in the catch block we can write the exact exception class as well as super exception classes. Even super exception classes can handle subclass exceptions, but it is always advisable to go with individual exception classes, and there can be multiple catch blocks within for the same try, but those catch blocks should be in the ascending order of the inheritance hierarchy. The catch blocks should be in the ascending order of the inheritance hierarchy that we have discussed yesterday, and it's always advisable to go for multiple catch blocks for multiple exception classes. And Within the same catch, we cannot write multiple exceptions like this. It's not possible. See, within the same catch, we cannot write two exception classes like this. This is not possible. A catch should have actually only one exception class. A catch should have one exception class. A catch should have only one exception class. So here we have kept two exception classes: class exception, arithmetic exception. So it's not possible. A catch can have only one exception class. If you want to catch arithmetic exception, then we'll write another catch. Like this, we write another catch for each and every new exception class. But this is not possible. This will give compile time error. Just I'm trying to compile the application. See, it is giving a compile time error. So we should not have multiple exception classes within the same catch. We should have one. At the same time, we should not have zero exception classes at the catch. Even this is not possible. Even this is not possible. We should not have zero exception classes at the catch. Even this is not possible. If there is a catch, the catch should have one exception class. No. What is the output? Before? N. Now is there any class exception in the first statement? No. Now in the second statement, is there any null pointer exception? No. So it will come to N. If there is no exception in the try block, then it will never reach, the control will never go to catch blocks. There is no exception in the try block, then the control will never go to the catch block. Now, is it possible to execute multiple catch blocks of the same try? Is it possible to execute multiple catch blocks of the same try? By any way, is it possible to execute multiple cache blocks for the same try? Yes or no? It's impossible. It's impossible to execute multiple cache blocks for the same try. Just because once there is exception in the try and that exception is being handled by the cache, the control will never return back to try. So at maximum only one cache block will be executed. Execution of multiple cache blocks for the same try is impossible. Execution of multiple cache blocks for the same try is not possible. Now the default value of A1 is none. Now in this case, what is the output? It's a compilation error just because A1 is non-static and A1 is being used directly in main method which is static. So I'll make now what is the output? Before catch, it's catch 2. Before and a null pointer exception is being arised in the 11th statement and it will come to catch 2 and then to n. At maximum only one catch block will be executed. Multiple catch blocks will not be executed. So let me go to the classes. Let me execute. Okay, before catch to n. Now in this case, now is there any arithmetic exception raised in the try? Is there any arithmetic exception raised in the try? No. Yes or no? No. Arithmetic exception is not raised in the try. Now, if that is the case, will it give you an error? In that case, if there is no arithmetic exception in the try, in this case, will it give an error? Yes or no? If arithmetic exception is not raised in the try, will it give a compile time error? Just think it logically. What is arithmetic exception? What is the type of arithmetic exception? And what I am asking? What I am asking is, if arithmetic exception is not raised in the try, will it give a compile time error? Definitely it will give a compile time error. Whether the arithmetic exception is raised or not will be known only to the runtime environment. It will not be known to the compiler. But for the compiler, there is a rule that if there are catches, then the exception classes in the catches should be in the ascending order. It's a rule for the compiler. So whether the arithmetic exception is raised or not, only known to the runtime environment. But if it wants to reach the runtime environment, first it should cross the compiler. At the compiler itself, there is a rule like, if there are multiple catches, then they should be in the ascending order. So it can be there. Like this. Now this should be compiled. Now what is the output? If this is compiled, what is the output? Before? Catch? Before? An exception. Why? Exception. If the exception is handled, okay, sorry. Exception is not handled, that's what you are telling, right? But why the exception is not handled? Which one? Which exception class is not there? Which exception class is not there? Now, is there any catch which can handle null pointer exception? Definitely, it will be handled, right? Now, what is the output? Before catch 3 end. Just because here the exception that is raised in the 11th statement is a null pointer exception, and null pointer exception cannot be handled by first catch as well as second catch and even third catch. Am I right? No. Runtime exception can handle null pointer exception. Runtime exception is a supermost class to all the unchecked exceptions. So all the unchecked exceptions can be handled by runtime exception. So the third catch can handle the null pointer exception. Okay? The null pointer exception which is raised in the 11th statement cannot be handled by the first catch, cannot be handled by the second catch, but it can be handled by the third catch. Just because runtime exception is a superclass to what is that? Null pointer exception. And when arithmetic exception is raised means when there are any mathematical failures. Like one of the mathematical failures are divided by 0. When we try to divide something by 0, then it is a mathematical failure. Now in mathematics, if you divide something by 0, what happens? It's infinite. Okay? But here, we don't have any infinite kind of thing. It will be a arithmetic exception. This situation will be a arithmetic exception. Whenever there is any mathematical failure, then it will be a arithmetic exception. One of the examples for mathematical failure is divide by 0. If we try to divide by 0, then it is a arithmetic exception. So it comes to catch 2. Now now what is the output? What is the output? Compile error. Why is the compile error? Unreachable? Which one is unreachable? Null pointer. Is there any null pointer exception here? Is there any catch with null pointer exception? Why do you think something is unreachable? Even STR is null, it will never become unreachable, just because it doesn't depend upon whether HCO or null at the time of compilation. See, unreachable statements will be verified at the time of compilation. At the time of compilation, the compiler doesn't know whether the STR contains HCO or null. That cases will not become unreachable statements. Okay? Now what is the output? Okay. Now what is the exception? Is there any exception in this line? Yes or no? Now is there any exception in this line? Yes. What is the exception? It's first a null pointer exception. Okay. So that it is going to catch 3. First what it will do? First a1 dot I by 0. First it will evaluate a1 dot I. Then it will evaluate a1 dot I by 0. But while evaluating a1 dot I, what happens? It's a null pointer exception. So in the highlighted portion itself there is a exception, and it will come to the catch block, which is runtime exception, just because the exact match null pointer exception doesn't exist. First, when it evaluates this content, the highlighted content, then it is a arithmetic exception. In order to evaluate a1 dot I by 0, first you need to evaluate the value of a1 dot I. But here itself it is a exception, null pointer exception. So this will not be evaluated. First, if you want to evaluate a1 dot I by 0, first there should be some value in a1 dot I. First it tries to fetch the value for a1 dot I. But since a1 dot I itself will give a null pointer exception, again the arithmetic exception will not be raised. Just because once exception is raised and it got handled, it will never return back to a try. Understood? So the output is before catch 3 n. Understood? Understood? Now this is how arithmetic exception is. And one more exception is array index out of bounds exception. Array index out of bounds exception. Array index out of bounds exception. Now let us see when array index out of bounds is exception is raised. Now it tells clearly that it is a array index out of bounds exception. Now let's consider that I have an array, a simple integer array. This is the integer array, right? So what is the size of this array? What is the size of this array? 3. Now what I am doing is I am trying to access like this. Now if we place some value here, will the runtime environment consider this as an index or a position? All of you know the difference, right? What is the index and what is position? Okay, index starts from 0, position starts from 1. Okay, if this is there here, if these are 3 elements of the array, see this is the first position, second position, third position. But here the indexes start from 0. At the 0th index 10 will be there, and at the first index 20 will be there, and at second index 30 will be there. So index will be position minus 1. Okay. So now what I am trying to do is I am trying to access the element at the third index. If I am trying to access the element at the third index means I am trying to access the element from the fourth position. Now how many elements are there? 3 elements are there, but I am trying to access the element from the fourth position or the third index. Third index means fourth position. If I try to do so, then it will be out of bounds. So the length is 3, but you are trying to access the fourth element, which is the exceptional scenario. The length of the array is 3, but you are trying to access the fourth element, which is always an exceptional scenario. That exceptional scenario is array index out of bounds exception. If we try to access an element which is out of bounds, if we try to access an element which is out of bounds from an array, if we try to access an element which is out of bounds from an array, then it is array index out of bounds exception. So we are trying to access some element which doesn't exist in the array. We are trying to access the fourth element from the fourth position, but it doesn't exist. So it is a index out of bounds exception. Array index out of bounds exception. See, let me give a null pointer exception, and the exception will not be handled. Let me give a null pointer exception, and so the exception that is raised is array index out of bounds exception, but it doesn't have any catch. So let me compile this. Let me compile. Classes execute this. So it says java.lang.array index out of bounds exception. Okay, the size of the index that we are using is 3, but that index doesn't exist. The array index out of bounds exception. Okay, what are the boundaries of index that we can use is either we can use 0 or 1 or 2. If you use 3 as the index, what happens? Array index out of bounds exception. Even if you use -1 or some negative value for index as of an array, okay, Even if you use negative value as an index for array, then it will give a array index out of bounds exception. Either we use negative value, or if you use some value which is greater than or equal to length. If you use some negative value or a value which is greater than or equal to length, then it is a array index out of bounds exception. If you use a index which is negative or which is greater than or equal to length, then it will definitely be a array index out of bounds exception. So now I have used the negative value. Okay, definitely if there is a negative value as an index, then definitely it will be a array index out of bounds exception. Okay, so there is a negative value, or now what is the length of the array? What is the length of the array? Length of the array is 3. Length of the array means the number of elements present in the array, 3. If the index that we are using is either negative or greater than or equal to length. Now, is it equal to length? Is 3 equal to the length of the array? Yes. So it will be a array index out of bounds exception. If the index that we are using is either greater than or equal to length or negative, then definitely it will be a array index out of bounds exception. Either if it is greater than or equal to length, or if it is negative, then it will be a array index out of bounds exception. So let me give another catch. Let me give another catch with array index out of bounds exception. Now what is the output? What is the output? What's the output? Catch for before catch for n, just because here there is no exception and here it is the exception, array index out of bounds exception, so it comes to catch for and then n. Okay, now will it be, now what is the output? What is the output? Now in this case, what could be the output? Before? Catch? 1. Why catch 1? See, if you are assigning string to integer, will it be a class test exception? Or it is a compile time error? Definitely this will be a compile time error. Just because args of 0 contains string. But can I assign string to integer? If we try to assign string to integer, then it is a compile time error, not a class test. If we try to typecast, then it is a class test exception. But if we are trying to assign some irrelated types, then definitely it will be a compile time error. This will be a compile time error just because args of 0. What is args? The derivative of args is a string array. String array of 0 means obviously it will return a string. So if we assign string to integer, it will be a compile time error. Okay? So on the right hand side it is a string, but on the left hand side it is a integer. So it is a compile time error. Now what happens? Now what happens? Before n. Now this output depends upon the number of command line arguments that we send. Okay. Now if we execute this application, okay, if we execute this application by sending 0 command line arguments like this, obviously it will come to the cache 4 just because the args length is 0, but we are trying to access the first element. The length of the array is 0, but we are trying to access the first element, which is a array index out of bounds exception. But if we try to access the same thing by sending some ABC as a command line argument, then it will not be any exception. This exception depends upon the data. Okay? So if we send 2 command line arguments, then also it will be successful. So if you don't send any command line arguments, then it will be an exception. Just because args contain the list of command line arguments. If the command line arguments is empty, and if you are trying to access the first element, if you are trying to access the first element from the empty array, it will be an index out of bounds exception. Okay, array index out of bounds exception. Understood? It will be like that. And this is something about some of the unchecked exceptions, how the unchecked exceptions behave. Okay? Now, let me discuss some of the checked exceptions. You understood, right? How the try catch will be and how the exception, the basic exception handling mechanism. All of you got it right? Yes or no? Are we habituated to multiple choices? Only if I give the options, then only you will give the correct answer, right? It's not the correct way. Now, let's discuss about some of the checked exceptions. A checked exception, as I discussed, is the exception that is recognized by the compiler. Some of the checked exceptions are java.lang.class not found exception, java.lang.clone not supported exception, java.io exception, SQL dot SQL exception. These are some of the examples for checked exceptions. But right now we discuss checked exceptions using class not found exception as an example. Right now we discuss checked exceptions using class not found exception as an example. Later on, when the time comes, okay, class not supported exception is used for some purpose. IO exception is used for some purpose. SQL exception has its own purpose. When that topic comes, we will discuss about these exceptions. But right now, we use class not found exception as an example to discuss checked exceptions. Okay? Now, when a class not found exception arises, okay, means now we have some. Now, how we can create an object for a class? New followed by a class name followed by parenthesis. Using new followed by a constructor, we create the object to a class. Okay. Now, there is another way to create an object. There is another way to create an object. Okay. That is using a class named class. There is a class named class in java.lang package. This class is a class in java.lang package. Don't be confused. There is a class named class in java.lang package. Okay. In the class we have a static method named for name. We have a static method named for name. Which takes a string. Which takes a string which is a qualified class name. That means a qualified class name means a class name along with the package structure. Dot the method new instance will create a new object. Class dot for name dot new instance will create a new object. So why this class for name is used to create object means there might be some scenarios where we need to dynamically pass the class name. There might be some scenarios where we need to dynamically pass the class name. In those scenarios what we do is we don't know at the time of compilation, at the time of development of the code, we don't know to which class we need to create the object. So what we do is we dynamically pass the class name as a string. By using the class name as a string we can create the object using class dot for name. Okay, so if we have class name as a string, then we can create an object for the class using for name method of the class. Just execute class dot for name of the class dot new instance. We'll create a new object. Now, this class exists or not? This class exists or not?
Yes.
Yes or no? Yes. This class exists. Okay. The class dot for name. Okay. At the runtime. Okay. A class not found exception object is created. At the runtime, a class not found exception object is created if the string doesn't represent a valid class. That means if the string has some invalid class. If the string has some invalid class, if the class name is invalid, just to simplify that, if the class name is invalid, then at the runtime, a object to class not found exception is created. If the class name in the string is invalid, then at the runtime, class not found exception object is created. If this is a valid class, at the runtime, class not found exception object will not be created. If this is a valid class, if the string represents a valid class, then at the runtime, class not found exception object will not be created. But if you want to go to runtime, first we should compile the application. What I told, this class not found exception is a checked exception or unchecked exception? Checked exception. So now if we use class dot for name, whether there is a chance to raise the exception at the runtime or not, it's irrespective. Just listen carefully. At the runtime, there may be or may not be a chance to raise the exception. At the runtime, there might be or might not be a chance to create the exception object. See, if the class name is valid, then the exception object will be created. Sorry, if the class name is valid, the exception object will not be created. If the class name is invalid, then the exception object will be created at the runtime. But it's the job of the runtime. But at the time of compilation, the compiler will check whether this statement raises a checked exception or not. Okay? Is this statement a checked exception rising statement or not? Actually, whether the exception is raised or not will be known only to the runtime environment. But whether there is a possibility to raise the exception will be known to the compiler. For checked exceptions, whether there is a possibility to raise the exception or not will be known to the compiler. So the compiler knows for name. That means if we are using for name, definitely we should handle that exception. Whether there is a chance of raising the exception or not, that known only to the runtime environment. But if we are using for name, means definitely we should handle the class not found exception. Just because it is a checked exception. If you use for name, definitely we should handle class not found exception. Okay? That's how the checked exception will be. See, the possibility of raising exception or the exception will be raised only at the runtime environment. First of all, let me concentrate upon only class dot for name. Okay, later on we'll discuss about new instance. Now, unreported exception, java.lang class not found exception must be caught or declared to be zero. At the time of compilation itself, it's recognizing that exception. Okay, this statement class.forName, okay, is a checked exception rising method. This method is a checked exception rising method. So whether the exception object is not created or not, it will be up to the runtime environment. Whether the exception object is created or not, it will be up to the runtime environment. At the time of compilation, the exception object will not be created, but there is a chance for raising the exception. If there is a chance for raising a checked exception, then definitely it will be a compile time error. Whether the exception is raised or not, it's not known to the runtime, it's not known to the compiler. The compiler only knows whether there is a chance for raising checked exception. Yes, there is a chance, just because we are using forName. If we are using forName, definitely there is a chance for raising checked exception. So definitely at the time of compilation itself, it should be handled. Okay, so we should handle the checked exception at the time of compilation. The compiler will compile the application only if this class.forName is surrounded by try catch. Otherwise, it will not compile the application. Just because there is a chance of raising a checked exception with class.forName. If there is a chance of raising a checked exception, then the compiler will not compile if it is not surrounded by try catch, or if that is not handled. The compiler will not compile if that is not handled, if that checked exception is not handled. Why means it is some exceptions are severe in nature. If they are severe in nature, then rather than imposing them to the runtime environment, the compiler itself will take care of that exception. So some exceptions are known to the compiler. So just we are taking pretty much care that it will be handled. But there are null pointer exception or the related exceptions are not that much severe. So they are data dependent as well as they are not that much severe. So they are shifted to the runtime environment. But this class.forName exception is a severe. This will be a definitely raising exception. There is a chance. There is a definite chance for raising the exception. If there is a definite chance for raising exception, then those kind of exceptions are made as checked exceptions. If there is a definite chance of raising exception, then those exceptions are made as checked exceptions by the Java developers. Okay? The developers who developed the Java software made the exceptions as checked exceptions if the severity is high and if there is a definite chance of raising the exception. That kind of exceptions are made as checked exceptions. Definitely they should be handled at the time of compilation itself. If they are not handled, the compiler will warn you with the error. The checked exception rising statements should be handled at the time of compilation only. If you are not handling them at the time of compilation itself, they will give a compile time error. Now let's consider like we have a null pointer exception. Just please observe here. We have a null pointer exception. Now will the compiler warn me with this exception? No, just because it is a runtime exception. But for checked exceptions, definitely if you don't handle them, and if you keep like this, if you don't handle them and if you keep them like this, then definitely the compiler will warn you with a compile time error that there is a checked exception and you should handle that. Okay, so If the checked exception is not handled, the compiler itself will give a warning, a compile time error. But it's not the case with the unchecked exceptions. For checked exceptions, the compiler itself will give you a compile time error if it is not handled. But for unchecked exceptions, the compiler will never give a compile time error. Now, is the checked exception handled means? Yes. Now, the class.forName may raise a checked exception. Class not for exception. Now, let me keep system.out.println. Now, it will be compiled successful just because it may raise a checked exception. It may raise a checked exception and the checked exception was handled. Now, it will be compiled successful, and if you go to the runtime, now let me give some things, some system.out.println. Before end. So go to SRC, compile the application, go to the classes, execute. Before and end is written. Now is it coming to the catch? No, just because this is a valid class. If it is a valid class, then at the runtime exception object will not be created. At the runtime, when the exception object is created and the exception object is handled by this catch, then only it will come to the catch class. Now, is it a valid class? Is it a valid class? No. So, let me go to the SRC, we compile the application, go to classes. Now is it going to the catch? Yes. At the runtime, the exception object will be created only when the class mentioned in the string is a invalid class. Understood? See, it will be a little bit confusing. See, whether the class in class.forName is a valid class or not. At the time of compilation, we should handle that exception. We should handle the class.forName exception. If we are using class.forName means definitely we should handle that, irrespective whether it is a valid class or invalid class. Just because it is a checked exception and it is recognized by the compiler. But the compiler doesn't know whether the exception will be raised or will not be raised at the runtime. The exception will not be raised at the compilation time. The exception and raised means the exception object is created. Objects will not be created at the time of compilation. Okay? The exception will be raised only at the time of execution. But if we are using forName means there is a chance of raising a checked exception. If there is a chance of raising a checked exception, then the compiler will recognize that and will give you a compile time error if it is not handled. If checked exception is not handled, then it will give you a compile time error, irrespective whether it is a valid class or invalid class. Whether it is a valid class or invalid class, if we are using forName means we should handle that exception. Then only the compiler will compile the application. Otherwise it will not compile. Whether the class.forName has a string which represents a valid class or invalid class, it's irrespective. If you are using class.forName means it should be handled. Then only the compiler will compile the application. Understood? Now what is the output? What's the output? Before n. Is there any exception rising statement in the try? No. So you directly come to n. So it will execute before and n. Okay. Now what's the output? Before n. Let us see whether it is before n or something else. What's giving? It's a compile time error. Okay. If there is a catch with a checked exception, then there should be the corresponding exception rising statement in the try. Otherwise, it is a compile time error. If there is a catch with checked exception, if there is a catch with a checked exception, if there is a catch with checked exception, then it's mandatory to have the corresponding exception raising statement in the try. If there is a catch with checked exception, then it is mandatory to have the corresponding exception raising statement in the try. Understood? So this is giving a compile time error just because there is a catch with class not one exception. Is class not one exception a checked or unchecked exception? Checked exception. There is a catch with checked exception. This definitely the compiler expects the corresponding exception rising statement. So now what happens? Before catch 1 n. It will give before n. It will come to catch 1 only if the class represented in the string is a invalid class. Now is it a invalid class? No, it's not an invalid class. It is a valid class. So it will come before and it will come to class.forName and it will come to n. So now let me give a class name as B. Now before error. Why this error? It's managed to give a package structure. That's why it is a compile time error. See whether the string is X or Y or Z or some Rajesh or HCU, it will not be known to the compiler. The compiler, whatever the string content means, it will consider as a string only. But what is the content inside the double quotes will be known only to the runtime environment. Okay, the compiler will consider double quotes as a string, whatever it might be. So it will compile successful. But the runtime environment will consider what is the content inside the double quotes. The content inside the double quotes will not be known to the compiler. If it is double quotes, then it will compile successful. What is the class? Whatever the class it might be. So at the runtime it will be exception. At the runtime the exception object will be created. Okay? At the runtime the exception object will be created just because it's not a fully qualified class name. It's just the class name. But we should not give just the class name here. We should give the class name along with the package structure. So it comes to the catch. Just because we did not give the package structure, we should give the class name along with the package structure. Then only it will create the object. Now, will it give a class not found exception? Will it create a class not found exception object at the runtime? Yes or no? No, just because it is a fully qualified class name. Understood? Now go to the SRC, compile the application, go to the classes, execute. So it gives before an end, so it never comes to the catch. Now if you want to create a new object, we execute dot new instance. Okay. Now again the execution of new instance also is a checked exception. Execution of new instance is another checked exception. It is instantiation exception. Sorry. So it is another checked exception. Execution of new instance is another checked exception. Execution of per name is a checked exception, which is, what's the checked exception for name? Class not found exception. Again for new instance it is another checked exception, which is instantiation exception. It's a instantiation exception. So for execution of this new instance, this is another, this highlighted portion is a checked exception rising statement. Okay? Again new instance is again a checked exception rising method. So now what's up? We have handled the instantiation exception. Now what is the output? What's the output? I'm asking what is the output? It will be a compile time error. Just because, okay, for name it is a checked exception. The execution of for name is a checked exception. The execution of new instance is also a checked exception. The execution of for name is a checked exception, which is class not found exception. The execution of new instance is another checked exception, which is instantiation exception. So if we are using both, then we should handle the both. If you are not handling class not found exception, again it will be a compile time error at the time of compilation. At the time of compilation, it will be a compile time error just because okay, we have handled class not found exception, but we have not handled, sorry, we have handled instantiation exception, but we have not handled class not found exception. So first we should handle class not found exception and then instantiation exception. Just because for name we have class not found exception and for new instance we have instantiation exception. Okay, now again it is a checked exception, which is illegal access exception. For this we have one more checked exception, which is legal access exception. This is for new instance. These two checked exceptions are for usage of new instance. Even illegal access exception is also a checked exception because of the usage of new instance. Now it was compiled successful. Okay, this for name arises one checked exception, which is class not found exception, and new instance arises two checked exceptions. New instance arises two checked exceptions. One is instantiation exception, another is illegal access exception. The new instance arises two checked exceptions. One is instantiation exception and illegal access exception. Now let's consider, like, if I am not using new instance, what happens? If I am not using new instance and if this is my application, what happens? Will it give a compile time error? Yes or no? Yes. Why it is a compile time error? Why is a compile time error? Try is not? If there is no new instance in try, what happens? In the catch we are having instantiation exception and illegal access exceptions. These two exceptions are checked exceptions. If there is a checked exception catch, then definitely there should be corresponding exception rising statement in the try. Otherwise it will be a compile time error. If there is an exception in a catch, then there should be corresponding exception rising statement in the try. So it is a compile time error. So definitely if there is a checked exception rising statement, there is a catch with checked exception, there should be corresponding exception rising statement. Otherwise it will be a compile time error. Now what's the output? What's the output? Before catch 1 n. Will it come to catch 1? Will the control come to catch 1 at the runtime? Yes or no? Will the control come to catch 1 at the runtime? No. Why it will not come? Just because this is a valid class name. Since this is a valid class name, it will not come to any catch. Directly it will come to n. So go to the classes. Try to execute. Before and there is no exception. Now let's consider like the class is invalid. If the class is invalid, what happens? Before catch one n. Just because the class itself is invalid class. So it will come to catch one and n. Let's consider like the class name is valid. Now what happens? Before catch one or catch two? Definitely it will come to catch two. It's a valid class name. Definitely it's a valid class name. There is no error. There is no class not found exception. Just because this is a valid class name. But this class cannot be instantiated. Just because it's an abstract class. Then it is a instantiation exception. Okay? This class is a valid class. Class not found check exception will be raised if the string is not a valid class. But this is a valid class definitely. But this class cannot be instantiated. Then it will come to the second catch. Just because this class is a valid class definitely. But this class cannot be instantiated. Just because it is a abstract class. So it comes to the second catch. Instantiation exception. Now, how we can create an object means let me try to like this. Now, the return type of new instance is object. The return type of new instance is object. Java.lang.object. The return type of new instance is java.lang.object. Now, what happens? The return type of new instance is java.lang.object. In that case, what happens? I said clearly that the return type of new instance is object. Then what happens? Why are you thinking for this much time? Why you are again and again telling class cast exception? When the class cast exception arises, if there is a typecasting, are we doing typecasting here? Why again and again class cast exception? It creates, see, it creates an object or not creates object, it will be done at the runtime. See, you have done the same thing. You yourself have asked the same thing and I have clarified that. and you could not able to tell the same thing. On the right hand side, what is the return type of new instance? Object. Can I assign object to B? Can we assign object to B? Is it possible to assign object to B? Yes or no? Definitely no. New instance, see what is on the right hand side? Ultimately the right hand side will return what is written by new instance. What is the return type of new instance? Object. Can we assign object to B? Can we assign java.line.object to B? No. Obviously it will be a compile time error. Just because on the right hand side the method is there and the method return type is object. On the right hand side there is a method, new instance. And what is the return type of the method? Object. So we cannot assign object to B. So definitely it will be a compile time error. Just if there is a method in the right hand side, then we need to check for the return type of the method. The return type of the method is object. The return type of new instance is object. So object cannot be assigned to B. So this is a compile time error. Now what we can do is, we can typecast into B. Now will it give a class cast exception? Will it give a class cast exception or not? No. Yes or no? No. Just because for which class we are creating the object? B. And into which class we are typecasting? B. So it will be a successful execution. It will not give a class cast exception. So, understood the advantage of typecasting? Now, can we write a new method for class A, class B, C, D, E, a separate method? Can we write a separate method which is new instance for class A, class B, class C, class D? Let's consider like I have 4 classes. And can I write a separate method of new instance which is for one for class A, one for class B, one for class C, one for class D, and one for string and one for system? Can I write like that? No. So we have made a new instance generic with a return type object, and if we want we can typecast that object into our own type. So the new instance method return type is object, and the returning object will be depend upon the class that we give. If we give B, it will create the B class object. If we give A, it will create the A class object. If we give string, it will create the string class object. But the new instance return type is object. So it can return any of the objects. But while using that object, what we need to do? We need to typecast into our type. Understood? That's the advantage of typecasting. Then what is the output? What is the output? Now it is a class cast exception. Just because for which class we are creating the object? A class. But to which class we are typecasting? B. So the A class object cannot be typecasted into B, which is a subclass. So now it is a class cast exception. Understood? This is how we can create an object even without using new operator. Okay? Even without using UO operator, we can create an object using class.forName by providing the class.new instance. The class.forName raises a checked exception, which is class.forName exception. The new instance method raises two checked exceptions. One is instantiation exception and illegal access exception. If you want to make use of them, then we should handle all the checked exceptions. And if there is a checked exception rising statement and if it is not handled, then it is a compile time error. And even if there is a catch with checked exception and if there is no corresponding exception rising statement in the try, even that is also a compile time error. Understood? This is how the checked exceptions will behave. Now, what's the difference between checked exception and unchecked exception? The first difference is compiler. Okay? Checked exceptions will be known to the compiler and checked exceptions will not be known to the compiler. Okay? We'll write the differences later on. Just up to now, what are the differences? There are some more differences. Okay? Some more differences are there, but up to now, the checked exceptions are the exceptions that are recognized by the compiler, but unchecked exceptions are not recognized by the compiler, they are recognized by the runtime environment. Okay? And for checked exceptions, if there is a checked exception rising statement, then it should be handled. Otherwise, the compiler will never compile. Okay? But for unchecked exceptions, the compiler will allow the compilation, but at the runtime environment will block the process of execution. Okay? But there is a catch with unchecked exception. If there is a catch with unchecked exception, then the compiler will never expect the exception rising statement in the try. But if there is a catch with checked exception, then the compiler will definitely expect exception rising statement in the try. The corresponding exception rising statement in the try. Up to now, these are the differences between a checked and unchecked exceptions. And the next concept will be propagation of exception objects. Propagation of exception objects. Propagation of exception objects, and this will take a minimum of 1 to 1.5 hour. The propagation of exception object will take a minimum of 1 to 1.5 hour. So it's not correct to discuss at this point of time. We'll discuss in the next class. When the next class means the same time, 6 to 8 in the morning, and my intention is to complete exception handling by tomorrow's class, if possible. Okay? And unless or otherwise I have some mandatory things to do, okay, I may have to go to office tomorrow. It depends upon the meeting with the client today evening. So I'll let you know, but at any case, tomorrow there will be a class from 6 to 8. But if we need not to go to office tomorrow, then there will be a class from 9 or 10 till we complete the exception handling. Okay, that depends. I'll tell you tomorrow. I'll let you know tomorrow. But tomorrow class will be there from 6 to 8. Okay?